All right, kids, this is section 8.2 on radian measurements, which is totally a new source of measurement that you probably haven't seen before, a way of measuring angles. Kind of like if you were to measure a piece of paper in inches, could you measure it in centimeters? Sure, it's just, and can you convert between the two things? That's really what we're into, is a different way of measuring angles. And it's this thing called radians. And the radian measurements are the ones that are more predominantly used in PreCalculus rather than the degree measurements, which you're more familiar with. So we are looking at this front page of your note packet, and we're actually going to skip over this and come back to it. I want to show you how to actually make the conversions before we actually create our circle. So you flip the page, and now you got this page. And here's what they're saying in the beginning. You can measure a meter, you could call it a decimeter, you could call it a centimeter, you could call it a millimeter. They're all just sources of measurement. If you're talking about a day, 1 day is the same thing as 0.1 decidays, go figure that. 0.01 centidays and 0.0001 millidays. Different forms of measurement just to measure something. In our case, we're talking about circles. And so most of you know degree measurements, and we're adding on a new type of measurement called radians, as I've explained. So let's review a little bit about circles. If I'm talking about the circumference of a circle, circumference is the distance around the outside of the figure. So I don't know whether maybe I'll highlight that. Okay. So if I go all the way around my circle, that's circumference. Now you probably learned this in geometry, that circumference equals pi times diameter, some of you might say. But that's also the same thing. Diameter is all the way across the circle. Some of you might say 2 times pi times the radius. That would also be a correct answer. Circumference, distance around the outside of the circle. All right, so there are some things on my circle. I'm going to make this like a hairy outer piece there. That's called the arc. Sometimes you'll see it as the arc length, the length of the arc, like the crust on a pizza. How big is that arc? And from the center of the circle to the edge of the circle, that's the radius, which is r. And we saw this when we did the degree notes in section 8.1, that the angle is actually called theta. We use that symbol, theta. Sometimes that's called the central angle because it's coming from the center of the circle. So you could see that referred to as the central angle. They just mean it's the angle that's coming from the origin there. And for whatever reason, they call this arc length S. Who made that up? What does S have to do with an arc length? Let me put the word length with that. The length of that crust on that pizza. Well, there's a formula for that arc length. And the formula, I'm going to come over to this formula here because it says arc length equals S. I'm going to put it above it because S is the arc length, equals the radius times that angle. If I want to figure out how big that crust is, I need to multiply the radius by the angle. But there's a qualifier with this. And the qualifier is that theta, your angle, must be in radians. If they give it to you in degrees, you have to convert it. So that angle, when you go to use this formula, has to be in radians. So let me give you an example. If I say that this angle is actually 60 degrees, we'll use degrees first, and then I'll talk about that a little bit. This is your S, that's your arc length, and your radius is 8 centimeters. And I say to you, find for me the arc length. So that's the distance from here to there. I want to know how big that is. So you would set it up and you would say S equals r times theta, S equals 8, my radius, times my angle that's 60 degrees. Well, I can't use 60 degrees, remember? We've got to have it in radians. Well, if I were, and I'm going to show you in a minute how to convert these, if I were to convert 60 degrees, it's the same thing as pi over 3. And so I multiply those two things together, and here's what it looks like. It would be 8 pi over 3, and you keep the same units that the radius was, so it would be in centimeters. And we're going to do more of this, especially section 8.3 is going to be on arc lengths and areas of sectors of circles. So that's coming at you, but that's just a preview. Couple more things to take into consideration. What if I took this formula and I solved for the angle? If I got theta by itself, I'd have to remove the r. It's attached by multiplication, so to get rid of it, I'd have to divide. So theta equals s over r. And so what happens is these radian measures, which we're going to be working on today, the radians equal the arc length s divided by the radius. So if I want to figure out a radian, I have to take the length of the arc and divide it by the radius, my bad, radius. Let me fix that. There you go. That's what a radian is. All right, so then they go to the next circle and they kind of reiterate this whole radius. If I'm looking at what the radian measurement is, what the angle measurement would be, the angle measurement comes from figuring out the length of the arc and dividing it by the radius. So they just use that circle as another explanation for what this says over here. Now let's investigate it just a little bit. If we said that this was 60 degrees, right? If I were to go another 60 degrees, right? And another 60 degrees. What happens is I've created half the circle, right? I've gone half the circle. Makes sense. Think about it degree-wise. 60 degrees, 120 degrees, 180 degrees. Well, 180 degrees is a straight line. So a straight line, that's what I've done. I've gone a straight line across. Now, we set up here, without showing you why, that 60 degrees is equal to pi over 3. Well, what if these things were all pi's over 3? What would happen then? I would have pi over 3 plus pi over 3 plus pi over 3, right? I've got 3 of them. Well, that gives me 1, 2, 3, 3 pi's over 3, or just pi. And so I've just seen that if I have 180 degrees in degree language, that equals pi in radian language. And we're going to see how, like I said, how to convert those two things. All right, flip the page, and we're going to come back to that unit circle in just a couple minutes. Think in radians. This is a lot of fraction thinking, kids. It's a lot of figuring out what the fractions are doing. All right, so my quadrants in my picture here stay the same. This is still quadrant 1. This is still quadrant 2. This is still quadrant 3. And this is still quadrant 4. None of that changes, whether you're in degrees, whether you're in radians. Remember, whether you go in positive directions or negative directions to get these angles, it's all the same. You know that this is, let me put the degrees on here first. We know that this is 0 degrees. We know that this is 90 degrees. We know that this is 180 degrees, 270, and I close my circle with 360. If I were talking degrees, that's where it would be. But I'm talking radians. Well, this is still 0. No pi needed. And we just saw on the last page that 180 degrees is the same thing as pi. We just showed that on the last page. So if I'm up here, how far to pi am I? If I think about it, it takes me pi all the way to here. This would be halfway to pi. Well, that means that this guy's half of pi. So 90 degrees is equal to pi over 2. (360 degrees is 2 pi. So if I go halfway between pi, 1 pi, and 2 pi, halfway between 1 and 2 is 1.5. Well, this guy's called 3 pi over 2. All right, I think what quadrant would these lie in? Let's go to our unit circle. I'll show you how this thing works before we actually do the conversions. All right, so let's put on our circle what we just were talking about. By the way, again, my quadrants, I'm going to put them on there. If I'm drawing an angle in standard position, the same thing goes as what happened in the first section, that you've got to start in this starting place right here, positive x-axis. You are starting here. Start here. My highlighter's running out. Start here. All right, let's go around the ones that we just talked about. This guy is 0. This guy up here we said was pi over 2. This guy is pi. This guy down here is 3 pi over 2. And I close my circle with 2 pi. That's the same thing that we just wrote on that other sheet. And again, these are the most popular angles. We're really creating the unit circle that we're going to be using quite a bit. But there are other angles that exist, not just these, but these are the ones that are most popular and the ones that are used on the unit circle. So this guy, this first guy that I come to, he is pi over 6. Now a lot of these I'm just going to give you for now, and I'll show you how to figure out how to get them yourself when we get to the conversion page. All right, this guy here is pi over 4. He's a quarter of the way. And this guy over here, he's my 60 degrees, that's pi over 3. That's a really bad looking 3. All right. Then I get pi over 2 at the top. And then I keep on going. And the next one I come to is 2 pi over 3, 2/3 of the way to pi. And then I get 3 pi over 4, 3/4 of the way to pi. And then I get 5 pi over 6. I've gone 5/6 of the way to a full pi. Now the rest of these are going to be bigger than pi, right? The rest of these are going to be between pi and 1.5 pi's. So now they're getting larger as I get into the third quadrant. So it turns out that this is 7 pi over 6, 1 1/6 pi. The next one is 5 pi over 4, 1 1/4 pi. The next one is 4 pi over 3, 1 1/3 pi's. And then I get to the bottom and I'm at 1.5. And then all the rest of these are going to be between 1.5 and 2. All right, so if I go further here, this guy here is 5 pi over 3. The next one is 7 pi over 4, 1 3/4. The last one here is 11 pi over 6, 1 5/6. And then I close it up at 2 pi. All right, before we go to the negatives, let's talk about this one more time in a different way. We're going to put these numbers outside the circle, because sometimes, occasionally, you'll see these angles in a decimal form. Now, don't let that scare you. You know, and I'm just going to put the main ones on here, that this is still 0 no matter what. But think about this. You know this answer. What is pi as a decimal? Right? You know that this is 3.14. Which means that my top is half of pi. 3.14 divided by 2 is 1.57. Now, we're not going to put all the individual ones around there. Just know that if they give you an angle that's between 0 and 1.57, it's going to land in the first quadrant. If they give you an angle between 1.57 and 3.14, it's going to land in the second quadrant. If I keep going down here, this guy is 4.71. If I take 3 times pi divided by 2, it gives me 4.71. And then 2 pi is the same thing. 2 times 3.14 is 6.28. So I could say to you, draw me an angle that's 5 radians. Well, if it's 5 radians, it's got to be between 4.71 and 6.28. So you would draw it and have it be in the 4th quadrant. So there's another conversion thing with radians that you could see. I don't know that you see it in this section necessarily, but it does come up occasionally. All right, let's go negativing. Negativing is going, you start in the same starting place, right? We saw this with the degrees. This is still 0. And notice you don't need any symbol next to it. The pi is, you know, your symbol for this guy to say that it's in radians. All you need to do is when you get to this place, you're exactly copying these, but you're going in a counterclockwise direction. So we're going to put all of these, pi over 6, pi over 4, pi over 3, yada yada, around the circle, but we're going to go in the negative direction. All right, so this one would be a negative pi over 6. This one would be a negative pi over 4, and a negative pi over 3. 3 pi over 2 is a negative pi over 2. See what we're doing? We're just going in the opposite direction. All right, then I've got a 2 pi over 3, so negative 2 pi over 3. I have a negative 3 pi over 4 and a negative 5 pi over 6. Pi is negative pi. If I keep going, then I'm at negative 7 pi over 6, negative 5 pi over 4, negative 4 pi over 3. You're going to get good at making pies. Right now they might be awkward. This guy here is negative 3 pi over 2 at the top. Keep going, and I am at 5 pi over 3, negative. Negative 7 pi over 4. And negative 11 pi over 6. Closing it up is a negative 2 pi. Nope, is that true? Negative, yeah. 2 pi, negative 2 pi, yep. Okay. All right, so if I said to you, what quadrant would the angle 4 pi over 5, 4 pi over 5, where would that fall? So think of it as working your way to pi. So if I was talking 4 pi, I'll write it over here. I'm going to erase it in a minute though. 4 pi over 5 is the one in question, what I want you to think about where that would land. You're going 4/5 of the way to pi. It's positive. You're going to go up. This is halfway. I need to go further than that. 4/5 is bigger than 1/2, and so I'm going to go bigger than that. But do I actually make it to pi? I'm going 4/5 of the way, and the answer is nope, I don't make it. So you would have an angle that's in the second quadrant, and that would be your answer to a 4 pi over 5 kind of thing. They're the next type of problems that we're going to do. on our sheet. All right, so keep your reference sheet handy, this guy. Let's go back to our note packet, and it says, what quadrants would these lie in? Well, first one, I'm going 2/3 of the way to pi. 2/3, it's actually on your unit circle that we just did, and you can see that if I'm 2/3 of the way to pi, I'm in quadrant 2. Right, you're looking at this guy right here, 2/3 of the way to pi. If I go, let's go down, negative pi over 4, that's listed on our thing, right? We've got a negative pi over 4. If I go negative 1/4, I am in the 4th quadrant. I went down to get that one. Now what about when they give you these improper guys like 7 pi over 5? Well, you have to actually convert that to a mixed number. I'm going back to like stuff that you might have done back in grade school. But if you have 7 over 5, that would be 1 with 2 left over. So it's 1 2/5 pi. Right, you want to convert that to a mixed number first so that you can see where it's going. And so if I go back to my circle, I'm going 1 2/5 of the way. Well, I'm starting here. If I go 1 pi, I'm over to here. But I need to go 2/5 beyond that. Am I going to make it to the 1/2? 2/5. And the answer is no, it's smaller. So this one would land in the 3rd quadrant. 1 2/5 is in the 3rd quadrant. 19 pi over 7. Well, 7 goes into 19 2 times with 5 left over. 2 5/7 pi. This one's going to be a swirly whirly. I'm going to actually just draw it right over here. All right, here's 1 pi. Here's 2 pi. A full circle, right? I need to go 5/7 more to pi. Am I going to pass 1/2? 5/7 is bigger than 1/2, and so I land over here in the 2nd quadrant. All right, let's do some conversions and see how these go. When I am converting to radians, now this is, I want it to be pretty bold, so let me see. If I'm going to go to the margin here too. If I'm going degrees to radians, right? They give you degrees, you're going to radians. You are multiplying by pi over 180. Pi over 180. And then what you're going to do is reduce your answer. So let me put that after this. Reduce degrees to radians. Multiply by pi over 180 and then reduce. So let's see what we got going on. So 210 is my first one. I want to multiply by pi over 180. And then here's what you're doing with this thing. It's kind of weird, but this is what the deal is. You want your answer to have pi in it. Now, we all know that you can go to your calculator and calculate out what that decimal value would be, but that's not what we're using mostly in pre-calc. We're using what the pi version would be, the answer with pi in it. So here's what you're going to do. You're going to pick any number you want that divides evenly into 210 and 180. I'm going to pick 10, right? That changes this to an 18 and changes this to a 21. So I pick any number I want. I chose 10. 10 got me a 21 and an 18. Well, is there another number that goes into 21 and 18 that I can reduce even more? Now you might say 3, that would be correct. You might say 6, that would be correct. You have choices. You can use any number you want, but the larger number that you use, the less times you have to reduce. Let me say that again. The larger number that you choose that goes into these two numbers will give you less times that you have to actually reduce. So we're going to go with 6. 6 goes into 18 3 times. I'm sorry, did I want 6? I didn't want 6. I wanted 3. I wanted 3. 3 goes into 18. Let me try again. 3 goes into 18 6 times. There we go. 3 goes into 21 7 times. And so what I just said about choosing 3 or 6 was not correct, obviously, for this problem. But what I said about picking the biggest number is true. You definitely always want to pick the biggest number you can that goes into them. Well, 7 and 6, there's nothing more I can reduce. So I take 7 times pi, put it over 6, and that's what's 210 degrees. Now let's look at our unit circle that we created, right? If I am at 7 pi over 6, I'm here. If I think about the degree circle we made the other day, what was the degree measurement there? And the degree measurement was 210 degrees, 180 plus 30 more. So you can see that that's actually correct, 7 pi over 6. All right, let's try the 135. 135, I'm timesing by pi over 180. Change my color so that it doesn't merge with that other guy. So I need anything that divides into 135 and 180 evenly. You could pick 5. There's something a little bigger. Anybody get it? If I pick 45, 45 goes into 180 4 times, and 45 goes into 135 3 times. And then I'm done, because ain't nothing going between 3 and 4. So my answer for this one would be 3 pi over 4. 3/4 of the way to pi is 135. All right, 88. Times it by pi over 180 and reduce. This one, I don't know. What goes into 88 and 180? Let's just go with 2. 2 puts me at 44 and 90. I can 2 again. 44 divided by 2 is 22. 90 divided by 2 is 45. And I don't think they have anything. 22, 45. There is nothing I can reduce with those. So 22 pi, so you can get some funky answers too, over 45. That's converting from degrees to radians. So, and I might make a note here under this, around this one, is this is a no calculator. You're not using a calculator for those guys. Whereas when you get to converting from radians to degrees, that's the, see, they give you the radian and they want to know what's the degree of that. When I go the other way, radians to degrees, this time I'm multiplying by 180 over pi, the reciprocal of that thing. So times 180 over pi. And this time I can use a calculator. Because what happens is, and you're going to see this in just a second, that the pi's cancel. The pi's cancel out, and then I'm left with just numbers that I can actually use a calculator to figure out. All right, so let's check it out. That's these guys over here. 3 pi over 4, you actually know the answer to that, because look at it. This was 3 pi over 4. What's 3 pi over 4 is a degree. It's 135, but let's see how they got that. I multiply by 180 over pi. And the reasoning behind that is I want my pi's to cancel, because remember, now I just want a number answer. I don't want pi in it. So pi, bang, bang, the pi's out of there. And then go to your handy dandy calculator and take 3 times 180 divided by 4. 3 times 180 divided by 4 is 135. And now you want the degree symbol with that, because now you're into degrees. Sometimes they might write the pi in a funny place, and that's what the next one is. But it's the same thing as 5 pi over 3. So work your magic. Times 180 over pi, so my pi's can cancel. Cancel the pi's. Take 5 times 180 and divide it by 3, and you end up with 300 degrees. And again, you can just use your little calculators to be able to calculate those values. And last one, pi over 9. If I'm looking at this guy, I multiply by 180 over pi. Pi by pi. 180 divided by 9 is 20 degrees. So they're your two conversions. You've got one that takes you, I'm going to bubble them in, one that takes you from degrees to radians and one that takes you from radians to degrees. That's the big deal. Big deal, big, 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 big. All right, last little bit. They're asking us to graph some of these. So 7 pi over 4, well, that's top heavy, right? So I want to make it a mixed number so I know where I'm going. 4 goes into 7 once with 3 left over. If I'm going 1 3/4, I'm going 1 3/4 more. So I'm over here in the 4th quadrant. And again, you don't have to be exact. You just need to be in the right quadrant. Oh my goodness, we're back into coterminals. They're going to make us coterminal for these guys too. Name a coterminal angle between 0 and 2 pi. In other words, it's positive, right? Because 0 and 2 pi is positive. So what's the positive angle for this guy? Well, you know me, I like to draw them. Some of you might be able to do these in your head, and that's fine. But if I am negative 11 over 6, I am negative 1. 6 goes into 11 once with 5 left over. Where am I? I'm 1 5/6 in a negative direction, mind you. So here's negative 1, right? I had to go down to make that angle, just like I did with degrees. And now I'm going 5/6 of the way more. 5/6 is not quite to close up that circle. So this would be my negative 1 5/6 pi. The question's asking, what's the positive coterminal angle? How big is this guy? This is where you need your fraction hat. If you think of this, they make a full circle together. They make 2 pi a full circle in pi language, a full circle together. And so if I've gone 1 5/6, how much would I have to go to be able to close that circle to get to 2 pi? And the answer is pi over 6. Right? Because it's a coterminal angle between 0 and 2 pi, pi over 6. Together, these add up to be 2 pi. Remember, the negative is just a directional thing. We talked about that in the last section. If I take 1 5/6 and I add 1/6 to it, that's going to be 2 pi. Some of you might write it that way, 1/6 pi. That's okay. You can do that. They're one and the same thing. Well, you'll see it more in this format than in the 1/6 format, which is why I wrote it that way. But 1/6 pi is the same thing. All right. I'm looking at the next one because I'm not so sure I love it. The question. We saw these in the degree problems too that the company put together, and I think I told you then that I didn't like those problems either. Let me do it this way. This is pi over 6 that they gave you. That's fine. This little piece is pi over 6. They're wondering, what's the measure of this angle? Well, I know it's a negative angle, and I know it's a negative 1 and something pi because it went past. If I stopped here, that would be a negative pi. It went past by that much. And the question is, how much is that much? So we know that every quadrant is worth 90 degrees, and 90 degrees is pi over 2. I'm going to write it down here. I know that the whole quadrant is pi over 2. But they took a pi over 6 chunk out. So if I take my quadrant, pi over 2, half of pi, and I take away pi over 6, in order to subtract them, I need common denominators. My common denominators are 6's. And so this would be times 3 pi over 6. This would be times 1. You don't need anything. And if I have 3 pi minus 1 pi, I have 2 pi over 6. And 2 pi over 6 is like pi over 3. Now, if you're not catching this, don't lose sleep over it. This is not a very significant problem and not something you're probably going to see on your test. So just, it's here, we're doing it, and there you go. So that means that my angle that I'm making would be 1 and, this is a third, 1 and 1/3, not fourth, 1 and 1/3 pi. I went 1 pi and a third more. What direction did I go in? I went in a negative direction, right? Well, 1 and 1/3 would be 1 times 3 plus 1. This would be the same thing as 4 pi over 3 in a negative direction. Whew! All of that to get that angle. And so they want, this is the one with the alls. And remember we showed them with the degree things, and we added plus 360n onto our answer. We figured out what the angle was, and then we added plus 360n. Well, guess what we're adding this time, because we're in radians. It's going to be negative 4 pi over 3, the angle we found, plus, instead of 360, it's 2 pi n, where n is an integer. Right, it has to be a whole number, positive or negative. Not a very significant question, children, so don't get your, in the scheme of what you need to know, that one's not high on the list. All right, let's try a few practice problems, and then we're going to call it a day. All right, I picked a few just to give you a flavor for these. Number 4 was my first pick. Number 7, number 9, number 14 on this page, and then a couple on the next page, and we're done. These are pretty quick. Draw an angle in standard position. I am negative 12 fifths. Well, I got to figure what that is as a mixed number. 5 goes into 12 2 times with 2 left over. 2 and 2/5 pi in a negative direction. All right. Start in standard position. Starting here. Here's negative 1 pi. I have to keep going. I'm going negative 2. Negative 2 pi. Then I'm going 2/5 more, so will I make it to the half mark? That's always about the half guy. 2/5 of the way is not going to hit the half mark. It's going to be down here somewhere. So you are landing in the 4th quadrant with your angle, and there it is. Number 7 is one of those weird guys like what we just were doing, but it's not a coterminal. It's just a regular, what's the angle? So the question is, how big is this angle if this other one's 11 pi over 12? All right, well, think, if I went all the way to here, I went pi in a negative direction. We're going to put the negative on at the end. But I need to know what this little scooch is right in here. What's that angle going to be? Well, if I've gone 11 pi over 12 to get to here, how much further do I have to go to get to pi? Pi would be 12 pi over 12. 12 over 12 is 1, so 1 pi. I would have to go 1/12 further. So I would have to go plus pi over 12, which means that I have, this would be 12 plus a little, if I make common denominators, this would be 12 pi over 12. Pi over 12 gives me 13 pi over 12, but I went in a negative direction to get there. So that one was a little trickier. By the way, number 1 got hole punched off. Number 1 is pi over 5. So if you go to do that problem, you're looking at pi over 5. Number 9, state the quadrant where this terminal side lies. You know me, I like to draw the picture. I am 5 pi over 4. I am 1 1/4 pi. And so if that's the case, I'm positive, by the way. So I'm going positive 1 and 1/4 more. I will not make it to the half mark. So I'm over here in the third quadrant is the answer to the question. What quadrant do you lie in? If I go to 14, 14 is a coterminal deal. We just did 5 pi over 4. I think this was really 15 pi over 4 and got hole punched off, but it's okay. It looks like a 5 pi over 4. We're going to go with it. 5 pi over 4, here's my picture one more time. 1 1/4. I need coterminal angles to this. And so one of my angles would have to go this way. Now think about that. If this is 1 1/4 pi, 5 pi over 4, how much further would I have to go to close it up to get to 2 pi? If I've gone 1 1/4 to get to 2, I need to go 3/4 more. So this guy over here is 3 pi over 4, but in a negative direction. Give one positive and one negative. Remember we talked about this the other day, that you have to have something different than what you're originally given. So my positive one can't be just 1 1/4 pi. I have to do that. I'll have to try it again. If I go in a positive direction and I stop there, then that's going to be 1 1/4. But that's the same as the original. So guess what? I've got to swirly whirl around and go stop it at the next time. So I'm going a full circle, 2 pi, plus I'm going my 1 1/4 pi. How far have I gone? I went 1 1/4 pi, but I did a full circle beyond that. So I guess if I looked at it this way, it'd be 2 pi plus 5 pi over 4. And so I'm going to, again, get common denominators. To put this as a 4, I've got to multiply by 4. So 8 pi over 4 plus 5 pi over 4 gives me, I don't know why I'm looking at this funny, but anyway, I've got 13 pi over 4. That's correct. I have it written differently on my other paper. It's 3 1/4, 3 1/4 pi, which is the same thing as what we're saying, 13 pi over 4. So all of our work there is good. Good to go. All right, a couple more. Quickly getting done here. 18 says find all the coterminal angles. One of those guys. Again, these are not ones that we love, but that's okay. You have to take the angle that they give you. Well, the angle they give you is this one, pi over 2. So I take pi over 2, and any circle beyond that is going to be a coterminal angle with it. So it's plus 2 pi n, where n is an integer. And that's all you're saying for that. You don't need to say more. So find the angle, like for 17, you're going to figure out what this angle is and then add plus 2 pi n onto it. And then the last ones are converting back and forth between degrees and radians. So I picked number 20. Number 20 is 280 degrees that I want to change to radians. So if you go back and look at your note sheet, you're multiplying by pi over 180. And you're picking any number you want that goes into 280 and 180. I'm going to pick 10 again because it ends with a 0. That gives me a 28 here. It gives me an 18 here. Is there something that goes into 28 and 18, and I can pick 2? 9 and 14. Anything into 14 and 9, and we say, nope, I'm done. So 14 pi over 9 is your answer. Last one is 24, 5 pi over 6. Going the other way, convert to degrees. times 180 over pi. Pi's cancel out. 5 times 180, go to your calculator, 5 times 180 divided by 6, and you get 150, and that's degrees. And so there you go. That's your deal on radian measurements. All right, your task is to complete numbers 1 through 26, and I will see you in class. Shoot me an email if you've got any questions, and I'll see you soon.